The last thing we need to talk about today is called the remainder theorem. The remainder theorem says this: if you are dividing by something, which is what we've been doing all day, we have a polynomial divided by some linear thing, you end up getting these, and notice that this is usually where our remainder goes. So what the remainder theorem is saying is that this remainder that you have out here is actually the same answer you'd get if you plugged C into your polynomial. So let me show you what I mean by this. Earlier, we did this problem in example 1. So I'm going to copy down what we got. We did 5x cubed minus 2x squared plus 1 equals, here we add x minus 3 times 5x squared plus 13x plus 39. Oops. Plus our remainder was 118. So now what I want to do is I need to plug in C to check my work. The best way to get C is to take what you were dividing by, set it equal to 0, and solve. And that is your C value. So what we're going to do is take this C value and plug it in to the answer, into what we started with. So I'm plugging 3 in. And if you plug that into your calculator, you will get 118, which is the same as our remainder. So we take what we were dividing by, set it equal to 0, and solve. And that gives you your C value that you plug into what you started with. And what we're saying is that when you plug in C, you should get the same answer as your remainder. So this is where the check step comes in. If you plug in C and this answer is different than your remainder, then you know you did your division wrong somewhere. You need to go back and check your work on the division. I love this check step because it takes about 15 seconds to type that into my calculator, and it can guarantee I get all the points on this question on the exam. It's a very fast, simple check step. So I want you to practice on the next two problems. Notice they're the same from example 1. So you're going to take this problem, you're going to write out your multiplication statement that you got in example 1. You're going to solve for what C is. You're going to plug that C value in and then double check that the remainders are the same to know that we did our division correctly. So pause the video and try that process out on B and C. Once again, write out your statement from example 1, solve for C, plug C in, and check that your answers are the same. Pause the video and try that out, and then come back and check your work. So let's check your work. I wrote up my multiplication statement, set this part equal to 0 to find my C value, plug that into what I started with, and I got 0, which is the same as the remainder. That means we did our division correctly. Here's my multiplication statement. I set that equal to 0 to solve for C. I plugged C into my equation, and I got this, which is the same as my remainder. That means we did our division correctly. So that's called the remainder theorem, and it's just a very quick, fast, easy way to find if you did your division correctly. So a good summary of today's lesson. We've learned that the following things are true. If the point C, 0 is an x-intercept of our function, then x equals C is a 0, or we call a root of p of x, and that's found when we set the equation equal to 0 and solve. Meaning we factor it out, set each factor equal to 0 and solve it, and we get that. That also means that x minus c is a factor of p of x, If x equals c, then x minus c, which also means when we plug c in, we should get a remainder of 0 using that remainder theorem. All of those things work and are true. So that is all for lesson 2.3, right? Yeah, 2.3. You are now ready to get started on your homework.